Now I'm going to show you how you can use a phylogenetic analysis to investigate the origins of the 2022 outbreak in Haiti. So we have just looked at how we can make a collection in Vibriowatch and in the last video, and by now hopefully you have waited a few minutes and the collection should have been made. To find the collection, go up to the three purple bars at the top left, click on that and go down to My Collections. And you should see the collection that you've just made at the top left, and to view it you can click on View Collection. This will bring you to the collection view, where you can see at the top left a phylogenetic tree, at the top right a map of where all the isolates in the tree were collected, and down below a timeline of when they were collected. By default, the isolates in the timeline are shown according to the month when they were collected, but if we want to change that to the year, we can click on the Settings button at the top right of the timeline panel and change day into year, and then we can click an X to close that menu. So now we can see that the isolates in the tree were collected between 2001 and 2022, and they come from basically all over the world: Americas, Africa and Asia. So in order to find the H22 isolate in this tree, we can go up to the search bar at the top where it says filter name and type H22, and this will highlight the H22 isolate in the tree. And you can see it's now shown over the country of Haiti. There's a dot and also 2022 as the year when that isolate was collected. Now this tree shows H22 and its close relatives in Vibriowatch, but actually some of the isolates are more distantly related to H22 and some of them are more closely related. So in order to just select this clade containing H22 and very close relatives, we can mouse over the ancestor node of the clade, and the number 111 pops up, which tells us that the clade contains 111 isolates. We can right click and select View Subtree. Now, in order to deselect the H22 isolate, delete H22 from the search bar at the top. Now what we see is that all the isolates in the tree are selected on the right. In the map we just see one dot. If you zoom out using the roller ball on your mouse, you will see that these all come from the country of Haiti. And down below in the timeline we can see that the isolates were collected in 2022, just one isolate, the H22 isolate, and also in 2017, 2015, 2014 and 2013. So this tells us that the H22 isolate was very closely related to the strain that caused cholera in Haiti in 2017, 2015, 2014 and 2013. Now we know that there was no cases reported of cholera in Haiti between 2018 and 2022. So what happened to cholera in between? Well, there's a couple of possibilities. One is that after 2017 there was no cholera in Haiti, but that it traveled out of Haiti to some other country in the Caribbean and then came back in 2022. But we don't have any evidence of that because we've no evidence of other countries nearby having outbreaks in that time period. So another possibility, which may be more likely, is that cholera somehow persisted in Haiti between 2017 and 2022, and it may have persisted either in people at a very low level, perhaps in remote regions with few cases, and also possibly there was an environmental component, so it may have persisted in the environment, perhaps in also both in the environment and in people, because we know that often when there is cholera in people, there's some contamination of the environment via sewage. So in summary, this phylogenetic tree can tell us some interesting things about the Haiti 2022 outbreak, namely that it was a very closely related strain as caused previous outbreaks in Haiti in 2017 and earlier years.